Hello, class. Welcome to Lesson 9 of Unit 5. All right, so on the screen you can see a diagram that shows Elena's method of finding 657 divided by 3. So we asked you to find the quotient in class, and we would have gone over this, but I want to go over here as well in case you missed it. So if you look, you can notice that in the hundreds area, there are 1, 2, 3, 4, 5, 6. 600, right? In the tens category, there are 10, 20, 30. So we have 630 so far. And if you count this here, you can count this as 9. So 639, and then 9 more. So 648, and then 9 more. So 657. So this is 657. That's the number that we're dividing. And we're dividing it by 3. So you can actually see here, this is one group, two groups, three groups. So 657 divided by 3 is the size of one of the groups. So you look at one of the groups, and you can see here 100, 200, 210, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. 219. Okay, so that's just another way to think of division. So you can picture how it actually works instead of it just being a bunch of numbers on a page. All right, let's take a look at the next part of the activity here. We have the title of the activity is using the partial quotients method to calculate quotients. All right, Andre calculated 657 divided by 3 using a method that was different from Elena's. Okay, so he started by writing the dividend and the divisor. Okay, so you can see here, dividend, divisor. So we have 657 divided by 3. And so he wrote it like that. Okay, you should be familiar with that way. What he did was maybe a little bit different than what you're used to. He then subtracted 3 groups of different amounts from 657, starting with 3 groups of 200. So he started with 200 here, and did 200 times 3, and that's 600, and he's got 57 left over. But of course, he's not done yet. He then went to find 3 groups of 10. That's where the 30 comes from. Subtracted from that and had 27 left over. That's the last part he has to account for. And so he has 3 groups of 9 to account for the 27. And now he's accounted for everything. He's got a remainder of 0. There's nothing left over. And then he goes ahead and he adds these 3 values, and he gets 219, right? So totally different looking from what Elena did, but they both arrived at the same answer. So we wanted you to discuss the following questions with a partner. We wanted you to see, okay, when Andre subtracted 600 from 657, what does the 600 represent? And it represents 3 groups of 200. 3 groups of 200, all right? He wrote 10 above the 200 right here, and then subtracted 30 from 57. How is the 30 related to the 10? Well, the 30 represents 3 tens that were distributed equally into 3 groups, right? 3 groups of 10. Okay, 2 hundreds, 110, and 9 ones. All right, and then down here, what do the numbers? Okay, sorry. What do the numbers 210 and 9 represent? Yeah, it's two groups of 100, 1 group of 10, 9 groups of ones. Okay, so that should be clear, right? That's pretty clear. What is the meaning of the 0 at the bottom of Andre's work? Well, 0, of course, as I said, just means no remainder. All right. How might Andre calculate 896 divided by 4? Well, of course, there are a couple different ways that you can calculate this, but Andre's method, okay, which may be different for some of you, is going to look like this. All right, so you can see here he takes 896, breaks it down to 4 groups of 200, so 4 times 200 is 800. Then 4 groups of 20, and that's 80. So after he subtracted 896 from 90, for 896 from 800, excuse me, he has 96 left over. And then so he breaks it into 4 groups of 20. That accounts for 80. And then 4 groups of 4 is 16, right? So the difference here is 16. And then once he gets the 4 groups of 4, he accounts for all of the values. He gets to no remainder. And so he gets 224 through that method. All right.